Yo te aviso.
Okay,
No
number-
yet, not yet, ahora.
Okay, number 2, continuation of what we were doing. So we had 3 shapes that you have to be aware of, all right? Well, we had the cylinder. You can see maybe a soup can here, a swimming pool here, maybe a hose here, something of that nature. They're all cylinders, and it's really easy to figure out the volume. For example, since the radius is half of the diameter, it's just the area of the circle, which is pi r squared, times whatever the height is. So there you see the formula right there. Pi r squared times the height. And it always works. So volumes are very easy with cylinders. So think again, a swimming pool, a soup can, maybe some sort of hose or something like that you use. Okay, the next figure that they want you to know, as we go a little to the right over here, is called a cone. A cone is always 1/3 of the cylinder. What I mean by that is the radius is the same. I could put the radius inside here, and once it's inside here, it would only occupy 1/3 of the total volume. Why is that true? We won't show that in 8th grade, but it is true, and that's all you need to know to do the problems. So the volume of any cone is 1/3 the volume of a cylinder when they have the same height and the same radius. We'll be doing lots of problems with these objects, so make sure you thoroughly understood what I did. It's important to copy down the formulas. Typically in a problem, they give you the formulas, but since you're learning at home now, you'll have them written out and you'll be able to do that yourself. We come over here a little bit and we're talking about the sphere. The volume for the sphere, as you see here, is 4/3 pi r cubed. Well, that's interesting. There's no height to a sphere. That's something that's worth keeping in mind when you're doing math problems, okay? So it's volume, the volume here is the radius cubed, no height. And it's also worth mentioning, very much worth mentioning, that you can cut this guy in half, say with a knife or a scissor or something like that, and you get a half sphere. There's the radius there, and that of course would be half of 2/3, half of 4/3, and if you work out the math very easily, you end up with 2/3 pi r cubed for the volume of a half a sphere, a semisphere, or a demisphere as they often call it, okay? So one more time, these are the 3 figures that you need to know, the volumes, the formulas. There's the soup can or the cylinder in its various forms. It can be sideways as well. We would imagine maybe a gas tank or something of that nature here. Here's a dunce cap or something of that nature upside down. So there are lots of ways to make these figures. We'll talk about that in the next talk. And over here, as I mentioned, there's the formula for the sphere. And then when you cut it in half, you have the volume for the half sphere over here. So these figures, you have to know the formulas, and you have to be able to put them together. And in a couple of minutes, I'll go on to the next part of what we have to learn. Okay, turn it off.